To supply a 100 amp main lug subpanel from a 200 amp main service, the appropriate wire gauge is essential for safety and performance. In this scenario, using 2/0 American wire gauge copper wire is recommended. The American wire gauge system is a standardized system for denoting wire sizes, with smaller numbers indicating larger wire diameters. Larger diameter wires can carry more current without overheating. Selecting the correct wire gauge is critical for several reasons. Firstly, it ensures that the circuit can handle the intended load. A 100 amp subpanel is designed to supply up to 100 amps of current to the circuits it feeds. Using a wire gauge that is too small for this current can lead to overheating, which can damage the wire insulation and potentially cause a fire. Secondly, proper wire sizing minimizes voltage drop. Voltage drop occurs when the voltage at the subpanel is lower than the voltage at the main service panel. Excessive voltage drop can cause appliances and equipment to malfunction or operate inefficiently. Larger wire gauges have lower resistance, which reduces voltage drop. Thirdly, adhering to electrical codes is essential for safety and compliance. The National Electrical Code, or NEC, provides guidelines for wire sizing based on the ampacity of the circuit and the type of insulation used. Local electrical codes may also have specific requirements. It is crucial to consult the NEC and local codes to ensure that the wire gauge selected meets all applicable requirements. Copper is a commonly used conductor for electrical wiring due to its excellent conductivity and resistance to corrosion. However, aluminum wire can also be used, but it requires a larger gauge to carry the same amount of current as copper. When using aluminum wire, consult the NEC to determine the appropriate size. The ampacity of a wire is the maximum amount of current it can safely carry. The ampacity of a wire depends on its gauge, insulation type, and temperature rating. The NEC provides ampacity tables that list the ampacities of different wire types and sizes. When selecting a wire gauge, it is important to choose a wire with an ampacity that is equal to or greater than the rating of the circuit breaker or fuse protecting the subpanel. For a 100 amp subpanel, the wire must have an ampacity of at least 100 amps. The insulation type of a wire affects its ampacity and its suitability for different applications. Common insulation types include THHN, THWN, and XHHW. THHN insulation is commonly used for dry locations, while THWN insulation is suitable for wet locations. XHHW insulation has a higher temperature rating and is often used for underground installations. The temperature rating of a wire indicates the maximum temperature at which it can operate safely. It is important to select a wire with a temperature rating that is appropriate for the environment in which it will be installed. For example, wires installed in hot environments may require a higher temperature rating. In addition to the wire gauge, it is also important to consider the type of conduit or cable used to protect the wires. Conduit is a rigid or flexible tube that protects wires from physical damage. Common types of conduit include rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Cable is a factory assembly of two or more insulated wires enclosed in a protective jacket. Common types of cable include non-metallic sheath cable and armored cable. When selecting conduit or cable, it is important to choose a type that is suitable for the application and that meets all applicable electrical codes. Non-metallic sheath cable, often referred to as Romex, is commonly used for residential wiring. However, it may not be suitable for all applications, such as underground installations or installations in damp or wet locations. Armored cable provides additional protection against physical damage and is often used in commercial and industrial settings. The NEC provides guidelines for the installation of conduit and cable. These guidelines cover topics such as support requirements, bending radii, and grounding. It is important to follow these guidelines to ensure that the installation is safe and compliant. Grounding is an essential safety measure that helps to protect against electric shock. Grounding provides a low resistance path for fault current to flow back to the source, which causes the circuit breaker or fuse to trip and to energize the circuit. All electrical circuits and equipment must be properly grounded. The grounding system consists of a grounding electrode, a grounding conductor, and a bonding conductor. The grounding electrode is a metal rod, pipe, or plate that is buried in the ground. The grounding conductor connects the grounding electrode to the main service panel. The bonding conductor connects the metal parts of electrical equipment to the grounding system. The NEC provides detailed requirements for grounding electrical systems. These requirements cover topics such as grounding electrode size, grounding conductor size, and bonding requirements. It is important to follow these requirements to ensure that the grounding system is effective in protecting against electric shock. When installing a subpanel, it is important to follow all applicable electrical codes and regulations. This includes obtaining any necessary permits and having the work inspected by a qualified electrical inspector. A qualified electrical inspector can verify that the installation meets all applicable requirements and that it is safe to operate. Working with electricity can be dangerous. It is important to take all necessary safety precautions to protect against electric shock. This includes wearing appropriate personal protective equipment such as rubber gloves and safety glasses, and energizing the circuit before working on it. If you are not comfortable working with electricity, it is best to hire a qualified electrician. A qualified electrician has the knowledge and experience to safely and correctly install electrical wiring and equipment. Remember that the 2/0 American wire gauge recommendation is based on copper wire. If using aluminum wire, a larger gauge would be needed to achieve the same ampacity. Always consult the NEC for specific requirements and ampacity ratings based on the wire type, insulation, and installation conditions. Voltage drop calculations are also crucial, especially for long wire runs. While 2/0 American wire gauge may meet the ampacity requirements, a larger wire gauge might be necessary to minimize voltage drop and ensure proper equipment operation. The length of the wire run from the main service panel to the subpanel significantly impacts voltage drop. Longer runs result in greater voltage drop. To calculate voltage drop, you'll need to consider the wire gauge, the length of the run, and the current being carried. Several online voltage drop calculators and NEC tables can assist with this calculation. The goal is to keep voltage drop within acceptable limits, typically 3% for branch circuits and 5% for feeders. If the calculated voltage drop exceeds these limits, a larger wire gauge is necessary. The type of load connected to the subpanel also influences the required wire gauge. Continuous loads, such as lighting and heating, require a higher ampacity than non-continuous loads, such as appliances and power tools. The NEC defines a continuous load as one that operates for 3 IOs or more at a time. For continuous loads, the circuit breaker and wire must be sized at 125% of the continuous load current. This ensures that the circuit can handle the sustained current without overheating. For example, if the subpanel will supply a 75 amp continuous load, the circuit breaker and wire must be rated for at least 93.75 amps, or 75 amps times 1.25. In this case, a 100 amp circuit breaker and 2/0 American wire gauge wire would be sufficient. The number of conductors in a conduit or cable also affects the ampacity of the wires. When multiple current carrying conductors are bundled together, they generate more heat, which reduces their ampacity. The NEC provides adjustment factors for ampacity based on the number of conductors in a raceway or cable. If the wires are installed in a conduit or cable with multiple other current carrying conductors, the ampacity of the 2/0 American wire gauge wire may need to be derated. This means that the wire's ampacity is reduced to account for the increased heat. The derating factors are specified in the NEC. The ambient temperature also affects the ampacity of the wires. Higher ambient temperatures reduce the ampacity of the wires. The NEC provides correction factors for ampacity based on ambient temperature. If the wires are installed in a hot environment, the ampacity of the 2/0 American wire gauge wire may need to be corrected. This means that the wire's ampacity is reduced to account for the increased temperature. The correction factors are specified in the NEC. The method of installation also affects the ampacity of the wires. Wires installed in free air have a higher ampacity than wires installed in conduit or cable. This is because wires in free air can dissipate heat more easily. The NEC provides ampacity tables for different installation methods. If the wires are installed in free air, the ampacity of the 2/0 American wire gauge wire may be higher than if they are installed in conduit or cable. The type of terminations used to connect the wires to the circuit breaker and subpanel also affects the safety and performance of the circuit. Use only terminations that are listed and labeled for the specific wire size and material. Proper terminations ensure a secure and reliable connection, which reduces the risk of overheating and electrical failure. Torque the terminations to the manufacturer's specifications. Over-tightening or under-tightening the terminations can damage the wire or the termination, leading to a loose connection. Use a torque wrench to ensure that the terminations are properly tightened. Inspect the wire insulation for damage before installing the wires. Damaged insulation can create a short circuit or ground fault, which can be a fire hazard. Replace any wires with damaged insulation. Protect the wires from physical damage during installation. Avoid bending the wires sharply or pulling them excessively. Use cable ties or other supports to secure the wires in place. Label the wires clearly to identify their purpose. This will make it easier to troubleshoot the circuit in the future. Use a permanent marker or label maker to create clear and legible labels. Test the circuit after installation to ensure that it is working properly. Use a multimeter to check the voltage and current at the subpanel. Verify that the voltage drop is within acceptable limits. Final note on safety: always de-energize the circuit before working on it. Turn off the circuit breaker at the main service panel before disconnecting or connecting any wires. Verify that the circuit is de-energized using a non-contact voltage tester.